to accomplish the mission requirements as per projected in the MAV08 rules. So we had to develop both MAV, the fixed wing, and the rotary wing, and the UGV, and we had to use all of them in our mission profile. The plan for completing the mission was to launch 3 fixed wing MAVs, which would go and identify obstacles and mines. We would plot that on the map that was provided and generate a path for the UGV to go. The UGV would carry a rotary MAV on its docking station and would launch this rotary MAV from the docking station near the final point. The rotary MAV would be carrying a sound sensor which would be dropped near the bank building and would go racing towards the perch point and try to transmit video images. And then we would give the commander to go and rescue the hostage. This was the equipment that we had used. The fixed wing, we had 3 categories. One that fit into a 300 mm sphere, one that fit into a 325 mm sphere, and one a little bigger than that. That was for the demonstration for Coral Autopilot, which was actually within 450 mm sphere. The UGV was a little bigger in size compared to the other UGVs, but we had a reason for that. That would be explained later. The UGV was developed by MS Ramaya, and we had done a lot of innovative things with the UGV. The rotary MAV was ready to commercially off-the-shelf rotary MAV, which we integrated with a small autopilot unit in that, which could do a mission as pre-programmed in the autopilot. And also it carried a sound sensor and a video camera. This was the mission plan for the smaller size MAVs. The 300 MAV would follow the flight pattern as in the image 1, and the second MAV would go through the flight pattern as in image 2. And this would be actually to identify the obstacles on the path and thereby map it on the map provided. The UGV, the specifications of the UGVs as given over here, and it had both autonomous and Wi-Fi control on the UGV. If we were able to locate the obstacles and the mines, as the blue dot shows the obstacle and the red dots, I had plotted out 2 red dots, would show the mines. The path would be defined with the UGV, and the UGV would go in this path, and also identifying a few other mines that it would find on its way. Now, this is the same mission profile as I had stated, the plan that we had to do, but things didn't go the way that we had planned. We had a lot of problems initially with the flight launch, and there was bad signal on the video, which we still couldn't proceed from there. Later on, when the UGV was launched, it was working fine when we had got it to the launch point, but the Wi-Fi link, we lost the Wi-Fi link, and there was a fluctuation within the link. So the UGV was let go when we had the link, and the signal broke, and it was in the acceleration command was given to it, so it had raced forward, but in the meantime we lost link towards the UGV, and it had accelerated towards the direction, thankfully not towards the crowd, but in the process we did also again establish link, and we did give the terminate command as ordered. But before that it went into the small mud pile and landed over there. So that is the mission profile that we had actually planned, and that was the things that I went through the our mission. But anyway, this also we had time actually to demonstrate the autopilot also, but we had problems from the UGV. The Wi-Fi from the UGV was actually jamming into the autopilot's link, so we couldn't actually launch the autonomous flight to give at least a demonstration of that. But we know that we can actually go ahead and demonstrate this within a 6 months' time. We'll be able to even come up with a miniaturized autopilot unit, which we are actually developing towards that, and we will be able to complete the mission as the mission profile given, and hopefully we'll do that very soon. This is the specification of the fixed wing MAV. Follows inverse Zimmerman, modified inverse Zimmerman profile with a ceiling 4083 mean camber aerofoil, and the propulsion system that we had used is a AXI motor, as we did a lot of tests on the motors and propellers, and this is what we found to be the most useful combination. Thank you.